Thank you. Thank you, and good morning to everybody in the room and watching on the live streams as well. It's my pleasure to be here today and talk to you about, the superpowers that I've been playing with, which is really the combination of IoT and AR. And when you put those together and put them to work in an enterprise, then very interesting things happen. And so I want to start just by introducing, my company and my own background. I'm the CEO of PTC. PTC is a large, call it, software company based in Boston. Our logo here is actually a P in white on top of a D in green, representing physical and digital. And it's a good way to describe kind of what we do and how we got here. We started 30 years ago when we invented 3D parametric CAD, a very famous product called Pro Engineer that's now known as Creo, and then a corresponding PLM product called Windchill. That were all about helping people conceive digitally and iterate on ideas that would later, when they're ready, become physical products. They'd be manufactured and delivered into the world. So that's sort of our heritage, is this idea of a digital mock-up, which became really a digital twin when we get to IoT and AR. Now, what's happened in the last 5 or so years is under my leadership, the company has invested about $1 billion building out a strategy around IoT and AR. And we've built, acquired and developed really 2 great brands. The Vuforia brand, which of course everybody who's in the AR market knows about, and the Thingworx brand, which is really a corresponding leadership position in the IoT world. And I really want to explain how these worlds are crossing and how businesses are putting them to work. So let's start with this idea, which is actually what that logo represents. That logo is just a stylized yin-yang symbol. But we had thought of physical and digital as a yin-yang concept for a long time. And if you know this yin-yang symbol, it's an Asian symbol that means 2 opposing forces that complement each other and make the story whole. So male and female, hot and cold, night and day, physical and digital. It's the physical world and the digital world that make what we now see as the whole world. And this is an interesting way to think about IoT and AR, because IoT, fundamentally, is about getting information from the physical world, from sensors, from control systems, what have you, and bringing it across the boundary into the digital world where we can analyze it and put it to work. So what do we do with it? This is some of the research that Professor Porter and I did. I'll get to in a minute. But we can use this data to monitor what's going on with physical things out in the world, physical things and environments. If we can monitor them, you could think about a bidirectional communication and turn it into a control system, remote control. You could then think about adding algorithms into that loop to try to optimize how things work. The wind turbine example shown here is that when turbines are located next to each other and the wind shifts around, the lead turbine changes. The lead turbine gets undisturbed wind. The turbines behind it get wind that may be disturbed by the lead turbine. And so they adjust their blades differently and so forth according to algorithms in the cloud. And then finally, if you could do all that, you could think about turning machines loose and letting them do their own thing, autonomous driving or autonomous factories and so on and so forth. So this is, some of the things that people are doing with IoT. And Professor Porter and I, Professor Porter, by the way, Michael Porter from Harvard Business School, very, very famous strategy professor. I got to know him some years ago because he used to be on our board of directors. He retired a while ago from our board, but we stayed in touch. And he and I did a lot of research and talked to many companies, many of whom are our customers, and wrote these 2 papers. And the first one was how IoT is changing the way companies compete. Really, it's changing their strategies around differentiation on one hand and operational efficiency on the other. And then we, in the second article, drilled into it's also changing what happens inside companies. It's changing the org chart, the structure of the company. It's changing the nature of work. It's changing the processes. So these articles, one written a little more than 2 years ago and second one written a little more than 1 year ago, were very popular, very heavily cited articles and so forth. But Michael and I kind of were a little dissatisfied at the end of the second one because we said, there's something missing. The world isn't just physical and digital, it's human too. And we kind of somehow miss this idea that humans need to interact with physical and digital. So we're off writing the third article, and sort of the thesis of the third article is that when we created things that are at the same time physical and digital, like a car, for example, we forgot to merge the experience that the human gets. So if you think of a smart, connected car, there is let's say you're on the left picture here, you're driving it. You see the physical world in front of you. You have a physical steering wheel. You have gauges. You have an accelerator, a brake, all that physical stuff. But if you want to engage the car digitally, you would either do it on your smartphone or perhaps with this navigation system type of concept. Now, if you think about the navigation system, when you're driving and you say, let's say you're in a neighborhood you don't know, you look at that navigation system and you really have to concentrate a little bit and study it. What do these lines mean? There's green ones, there's red ones, there's heavy ones, there's light ones. What does that mean? And what is the scale of that? And by the way, is it north up or ahead up? And so you got to study that, and it takes a lot of brain power, what we would call cognitive load, to figure out what that information means. Then you have to memorize it, because you're going to switch your gaze over to the physical world and try now to interpret all that. And the difficulty in interpreting it would be called cognitive distance. So there's a big problem of cognitive load and cognitive distance as you move between these modes of interacting with your car. And how many times have you been studying that GPS navigation system and you look up and you find you've drifted over the center line into the other lane next to you? Happens a lot because you can only concentrate that deeply on one thing. So there must be a better way to converge together the physical and the digital experience while driving a car. And so that led us then to this idea that, hey, wait a minute, AR is really the counterpart to IoT. AR is about taking digital information, crossing back over the line into the physical world, and putting it in a physical context. So we saw that IoT and AR belong together and, in fact, need each other. AR isn't very interesting if you don't have any content to augment. And IoT isn't that useful if it produces complex information that people can't interpret. But if you connect them together, then really amazing things could happen in sort of an ongoing circular flow of information. So, for example, you could create a heads-up, active, augmented display. You could put in the screen of the car, like you see here, a little panel that shows digital information overlaid in your field of view, and that way the human driving the car is benefiting from the digital and the physical experience at the same time. The problems of cognitive load, the problems of cognitive distance diminish, maybe even disappear entirely. It's a big, powerful concept to have this type of experience. Now, that said, I'm not sure that the idea of putting it in your windshield's the right answer. In fact, I'm a private pilot, and I was reading Flying Magazine a couple of airplane flights ago, and I came across this picture. They had a story about heads-up displays. And it was, sort of an AR-ish kind of concept that we can put information in your field of view and so forth. And I thought, that's interesting, but here again, we're talking about a dedicated display. You see the bracket hooked into the ceiling of the aircraft. We're talking again about a dedicated display. And so I was sitting in my kitchen last week. I have a nice kitchen. And I was sitting on that closest chair, and I looked around and I said, my God, we're swimming in heads-up displays. In fact, I did a quick little tour with my cell phone. The oven has basically a heads-up display. So when I look at the oven, I see information about the oven. It happens to be showing the time here. The coffee maker is telling me, Jim, I'm ready to make you a cup of coffee. And by the way, I can make espresso or coffee, and you can clean and run maintenance and do all that kind of stuff. The microwave has a display that wants to talk to me. The dishwasher wants to talk to me. The freezer and its companion, the refrigerator. And then I also have those dish drawers. And everywhere I look, there are things that want to talk to me, but they don't know how, so they've embedded displays, which quite frankly are pretty cryptic, hard to use, hard to understand, quite frankly not that useful. I mean, I don't know about you guys, but if you look at my microwave, it's got, breakfast, lunch, dinner mode. I mean, all I've ever done is punched in 130 start. I don't even know what that stuff is, and I don't have time. So it occurred to me, what if I could virtualize all of that? Get rid of all of that mechanical, physical stuff, the circuit boards, the displays. Hey, by the way, one of those ovens, at my previous house, I had the same oven. It's a Wolf. That display failed, so I couldn't turn the oven on. I had to replace that $1,300. I was like, I didn't think an oven cost $1,300. I know now they do, but the point really is that, this ain't working for me, right? But if we could virtualize this, and I could maybe put it on my phone or tablet, or by God, if I could put on my glasses and look at these things and see information that was easily customizable, and so that'd be fantastic. So I got on this idea, virtual heads-up display, okay, using augmented reality. And now you think, how do you make that work at scale? Because in the physical world, there are so many different types of things. Even if you take something like an oven or let's just say like a washing machine in your laundry room, there are many different washing machines from many different vendors. And even when you pick one, there's a whole bunch of different options you can get on it. Like the dryer could have the steam option or not, and so forth. So the amount of variability out there is just incredible. So how do you get data from many different things, process it, and map it back onto many different things in a sort of AR experience? And the answer is the digital twin. So it turns out that basically any manufactured thing that's come out of a factory in the last 20 years has a 3D model, because it's actually the 3D model that's the input to the factory to say, hey, go build this. And here's everything you need to know in order to build exactly what we've come up with. And so now our digital mock-up can be used as a digital twin. We can have a digital understanding of virtually any physical thing. We could take this IoT data, map it onto the digital twin, and then transpose it from the digital twin onto the physical counterpart. And so that sort of brings me to a just slightly more detailed version of the same concept, which is sort of a circular flow here. So if we start at, call it 1 o'clock, we're going to use sensors and other ways to collect data. We're going to bring it across the boundary. Now that's frequently called OT data, meaning data from the operation. We might combine that with IT data because there's a lot of databases, CRM systems, and so forth, PLM systems that have really interesting information. We want to understand the concept, map it onto that digital twin and analyze what is that data telling us. Because sensor streams aren't really that interesting or useful, but they encode information that's extremely interesting and useful. You just have to figure out how to decode it. By the way, some people say data is the new oil, and I say, well, then you need a new refinery, because you're going to have to figure out how to turn a crude raw product into a valuable byproduct that you can put to work. Okay, so once we've analyzed the data and we understand what the world's telling us, now frequently I want to make something happen. I want to orchestrate a response, and to the extent that response involves people back in the physical world, I want to transpose this information into an AR experience that they can use with that object or environment that's right there in front of them in the physical world. So this is a concept. It would be better if we had a demonstration. So that's where I want to go with it. I want to demonstrate this scenario right here. And this is that triangle of physical, digital, human, in a way. So from a physical standpoint, we have this motorcycle. Some of you saw Jay Wright yesterday show this motorcycle for a little snippet of his part. I'm going to show you the kind of complete cradle-to-grave story behind the motorcycle. So the motorcycle has sensors. It's streaming data up to the cloud. And in theory, the cloud can stream commands back to it. Now, there aren't that many useful commands you can send to a motorcycle. I suppose you could say start or something like that. But if you go with things generically, there are a lot of commands you can send to them. I could turn my oven on or off and set the temperature and so forth. Now, on the other hand, the user, represented by the hands holding the iPhone there, is using computer vision to see the motorcycle and AR to decorate it with digital insights. Where do they get the digital insights from? Well, they pull them down from the cloud. And the user, using a voice command or a touch command or something like that, could send an instruction up to the cloud and back over to the motorcycle. So the user could say, motorcycle start, and off it goes. So this is kind of that triangle where the user is talking to the digital and the physical at the same time. The motorcycle is talking to the cloud and the person at the same time, and so forth. It's a nice little thing. So I want to take you through kind of a demo to show this, and just to show it's a real concept. This is me sitting on the motorcycle a couple days ago back in Boston. Now, it's hard to bring that motorcycle on the airplane, so we have the toy counterpart. Now, the interactions are the same, except the data, of course, is fake. There aren't really sensors on this toy sending data to the cloud. You'll have to just pretend there are. So the basic concept is, let's look at the digital twin. That motorcycle came from a 3D model. So the 3D model is a perfectly accurate representation of the motorcycle. The model begot the motorcycle, not vice versa in this particular case. So we can slice and dice and zoom in and really understand the DNA of that physical motorcycle. We can do some other interesting things also in similar software. For example, we could create 3D documentation. we could say, let me explain to you how to take that back wheel apart. So we're going to zoom in. We're going to go into the step editor because we're creating a step-by-step process here. We're looking at a few different steps that have already been authored, and we played those, and now we want to do a little bit more authoring, so we're going to add a new step down the bottom. We're going to say, take those 2 bolts on the brake caliper, unscrew them using a counterclockwise rotation, then take the bolts and the caliper and move that whole thing down and out of the way. So slide it down and out of the way, then we'll add another step to grab that kind of orange-looking bracket, not sure what to call that, slide that out of the way, and now we want to take the bolts out of the disc in the disc brake. Some of them are easier to get from the backside, so we identify those, screw those out, and so we just authored a procedure. Now it turns out we could do that 5 years ago. We just didn't know what to do with it. We would play it on your laptop, and then you'd have that cognitive load, cognitive distance problem. But when AR enters the picture, it's very interesting because now we could decorate that not on your laptop, but right onto the actual motorcycle. So the next question is, how will we recognize the motorcycle? And you saw this from Jay Wright yesterday, CAD recognition, or more generally said, object recognition. We could say it's shaped, it's a 3D thing. It has a shape like this. Let's give the user a hint, like that black and white picture on the right. And now we've explained how this experience should identify its counterpart in the physical world and attach itself. And then the last step, I'm going fast here, by the way. The last step is how do we bring that all together into an AR experience? And here we're in a drag and drop authoring environment where I'm going to say, bring in those files, bring in the digital twin, bring in the procedure, bring in the target, and let me create an experience. Now, I want this to be 3D. So this is kind of like a web editor, but it's a 3D web editor. So bring in that digital twin. Here we go. Okay, the first thing I want to do now that I have it in is I want to load that procedure. So I'm going to come down and select amongst those resources I loaded. There's the procedure. And I'm going to say I want to attach that procedure to a 2D button on the glass, not to the motorcycle, but to the glass of the screen or to a voice command. So now I'm going to say put an icon there. The icon should look a little bit like a play button. Whether it's pushed or not, I guess I'll have it look the same. And then I want to create an event association so that if somebody pushes that button, then we play all the procedures. I could have picked the one, but there is only one. So play all the procedures and so forth. Now we're moving on and we're putting gauges on the motorcycle, not on the glass of the screen, but on the motorcycle. So we placed a generic gauge, and we're going to cut and paste a couple of them because we want a couple of different gauges. And so we placed the gauges, and now we're going to go up to the cloud. Basically, this motorcycle has an API. And we're going to go up to the cloud and say, from the API, I'm drilling it, from the cloud, I'm drilling into this motorcycle, and I want to pick battery, temperature, and fuel, and bring them into this experience. And then what we're going to do here is bind them to these 3 buttons. So make the button on the gas tank look like a fuel button, and bind it to the API in the cloud that measures fuel coming from the sensor on the motorcycle. Do the same thing with the battery, and then we'll do it one more time here with the last gauge, which we're going to make look like a temperature gauge, and it's going to give us the temperature of the engine on the motorcycle. So we've bound all these things together. We're going to come back, add one more button that turns all those things on and off, so I can have a button that turns the gauges on or makes them go away. So I'll do that quick and just linking that stuff together. I'll make that button look kind of like a sine wave, and I'll link that button to the display of these 3 different things. That takes another second or two. And then we're going to save this and publish it to the cloud, and we're ready to go. And if everything works right, when we're ready here, okay. So the last thing there is hit that publish button. And I'm going to log into my phone, which I'm going to do before I plug it in, okay. Just in case I had to use the keyboard method. Now, hopefully you're going to be able to see what's on my phone. Yes, no? Hello? You guys having trouble displaying? Here we go. So my phone says, hey, Jim, you should be looking for something that looks kind of like that. And so as I come down here, it's going to recognize and lock onto this motorcycle. I think it's going to recognize and lock on. There we go. And so here's now this display. And if you look, you can see the gauges, so 5.4, no, 5.49, 5.1 liters. You can look at the battery, 48, 47, 51. Again, we're just using an algorithm to generate data there. And I could go ahead and, before I do it, though, I want to just show you something. Just study that motorcycle for a second. Because in this little experience, this is a slightly different version than the one we just authored because we added another thing, which is if you study that motorcycle, you can see it going back and forth between a physical toy and a digital twin. So right now it's a digital twin, now it's a plastic toy. Now it's a digital twin, now it's a plastic toy. So it's a kind of an interesting thing. And then I'm going to hit that play procedure and take that back wheel apart. Again, slightly different version of authoring here, but same basic concept. And I could say, put that back together and turn the gauges back on, and turn the gauges off, and so forth. So that was the demo, just to show you some concepts. So, when's the last time you saw a CEO of a public company give a live demo? All right, so moving on here, I want to get back to the Harvard Business School research. There's a lot of people saying that AR is going to rock the world, and I think is going to, the business world. You know, quotes here from IDC and Forrester and so forth. I won't spend a lot of time on them, but like IDC says, it's clear that there will not be many businesses that aren't impacted by this, and that's really what our studies showed as well. And that this may be as transformational a process as the PC was. So let's drill into it and say, what are people doing with those types of technologies, with AR particularly in the enterprise? Well, first they're using it to visualize things that can't be seen. They're bringing in digital data, blending it, holograms, data, procedures, to create an experience that you can't see with the naked eye. The second thing they're doing then is showing you how to do things by putting digital overlays of instruction sets and so forth onto physical reality. And the third thing they're doing is giving you a new way to interact with things through voice commands and buttons and so forth in your experience, hand motions, you name it. Turn the motorcycle on by, clicking crushing your butterfly or whatever you want. Now, where are they doing this? So we talked to hundreds of companies, and I got to tell you, they're doing it everywhere. And again, I'm mostly talking to industrial companies here, industrial enterprises, but they're using it for holograms and design reviews and collaborative experiences. They're using it in their factories for maintenance instructions and assembly instructions and performance dashboards, a whole new generation of human-machine interfaces. They're using it in sales and marketing to create companion applications, but to also create virtual or digital showrooms, show you products that are actually holograms, maybe have one physical one, but infinite variability in holograms to complement the physical one, so you can see and touch one, but then I can show you any of these mathematically explosive list of combinations of features and options in hologram form. You go into service, obviously they're trying to get to 3D documentation, augmented, but they're also doing like inspection and verification. Like, I know how this system should look. Is it actually arranged that way? And by overlaying the how it should look on the how it actually is, I can see discrepancies and problems that have to be repaired. People are using it for all kinds of interesting training opportunities. And then, of course, it's completely changing the way people operate things. Again, work instruction, sure, but dashboards and controls, it's a whole new human-machine interface, really, that's coming together here. So it's very exciting. Now, we have many customers at PTC, and for our AR blended with IoT technology, we're starting to get quite a few. We have a couple thousand, actually, working on that idea, and the reason we have a couple thousand is because it's so darn interesting to them. I mean, people are lining up literally to play with this technology. Some of them are taking it into production, but a lot of people are just trying to figure out what would we do with it. What we found amongst the people we've surveyed, here's a survey of the first 80 or so people we talked to, is they're doing all kinds of things. Just like I said, you could do all kinds of things. People are doing all kinds of things. They're using it in almost equal amounts across service, manufacturing, sales, and marketing, and design. And if you drill down another level and say, what's the use case? There's a lot of step-by-step instructions for factory and service. There's virtual product companions. There's training applications, and more remote expertise, which, of course, if you take that chalk idea that Jay Wright from Vuforia introduced yesterday, that's a big deal, for remote service operations and so forth. Now, if you wanted to go build an experience like this for an enterprise, we've studied this a lot, in our HBR research, and we think there's at least 5 big questions that you're going to have to think about. So the first one is, what capabilities are you trying to do? Are you trying to help people visualize stuff? That's actually fairly simple. Are you helping them you're trying to instruct and guide them through some kind of a procedure or process? That's a little bit more complicated, and it's going to require you to have more different kinds of data to author against. Or are you trying to actually give them a full-on next-generation human-machine interface that controls something? You're going to have to take it even to another level. The second question is, where are you going to get the data from? Are you going to just build your own data, sort of like a Pokemon that's just authored by somebody out of thin air? But Pokemons aren't that useful in the business world. You're trying to give them experiences against things, against settings and factories and so forth. You actually need to figure out how to get data about those things and settings and put it to work. And some of it might have to be real time. Some of it could be drawings and models that you reuse, but a lot of it has to be real time, what's going on right now. Then the last thing is, or not the last thing, the next thing is, how are you going to map it onto the experience? Models, markers, what have you. How are you going to develop it? Are you going to pay somebody to develop it? You're going to develop it yourself, or are you going to try to do what I showed you here, which is more of a content play? And then finally, what hardware are you going to need? Now, I want to show you could put those 5 questions into a spider chart and map some ideas against them. So the basic idea of I want to put a product visualization out there. I want to put a coffee maker on the counter on a Target. That's pretty simple. You can just do this simple, fast, works today, etc. But if you want to do more enterprise things like manufacturing quality assurance to compare the design to the actual, that's a little bit more complicated. If you get into service instructions, you're going to have a much more sophisticated situation to deal with, and you're probably going to need hands-free capabilities in some kind of a wearable. And if you want to do a performance dashboard, again, you're going to need real-time data and so forth. So I'm sort of telling you a lot of these problems aren't that easy to solve. All right, so I'm running out of time here, and I want to wrap up, just leave you with 4 big questions that I think you have to think about, even bigger than those 5, sort of big strategy questions. Number 1, is this going to actually change products? If you make products, is it going to change them? All those things in my kitchen could be done very differently. Second thing is it going to change your process or your customer's process? For example, I can make a service technician more efficient, or I could think about getting rid of the service technician and actually allowing the customer to do a fair amount of self-service themselves, get rid of the technicians and the trucks and all that stuff, and begin to dynamically push this content out to the customers and then engage them with interactive chalk-type experiences and so forth. The next thing is this just one more way to create information, or does it actually start eating into some of the kinds of ways you do it today, like your web technologies and mobile technologies? I mean, I think at some level, this is the next generation of the web. It's just a 3D web. In fact, the concept I showed you was an authoring tool, a server, and a browser. It's just they were built around 3D concepts and things. And then finally, the last question is, when is this going to rock your world? Because I think it's going to. If you're too early, you waste a little bit of energy. If you're too late, you get run over by it. And my personal view is it's coming pretty fast. And I always tell people, when you see a really great wearable, the dam's going to burst. Because a lot of the problems here are solved or solvable, with the exception that I think the industry has to advance a little on the wearable front. Great progress being made, but there will be some kind of a breakthrough moment where we get that killer device, and then this stuff is just mainstream and commonplace. So, okay, with that, I'm out of time and then some, so thank you for this opportunity to come and talk to you this morning.